On this 6.7 Power Stroke Super Duty, P0101 is a mass airflow range or performance fault. In plain language, the PCM may be seeing airflow that does not line up with what the engine model expects. The truck may feel down on power, may be in a warning or derate strategy, or may just have the light on. Broadly, think possible MAF contamination, intake air leaks or restrictions, aftermarket air or exhaust changes, sensor wiring, crankcase ventilation or charge air leaks, EGR-related airflow effects, and, only after the rest of the path checks out, a possible control module side issue. For this code, the key quick check is simple. Look at the MAF sensor for contamination and look hard for intake air leaks. The setting logic is based on the measured airflow not matching the modeled value for 4 seconds. Start with the basic system checks and follow a structured diagnostic approach. If other intake air, sensor circuit, or communication faults are present with P0101, do not just chase the performance code first. Diagnose circuit faults before range or performance faults. Also keep in mind that regeneration can bias the values you are watching. If regeneration starts during testing, let it finish before continuing. With P0101 in this group, begin at the MAF IAT sensor connector. Key off, disconnect the MAF IAT sensor, key on, and measure between C128 pin 2 and C128 pin 3. You want 4.5 volts to 5.5 volts. If that is correct, continue into the intake system checks. If it is not correct, stop this airflow path and handle the sensor voltage circuit problem before going farther. Next, with the ignition off, inspect the intake air system as a system, not just the sensor. Check for correct installation, damage, leaks, and restrictions. Look for throttle body bore sludge. Check the crankcase ventilation system for leaks or restrictions, and check the charge air cooler system for leaks or restrictions. This is also where aftermarket accessories and performance modifications matter, especially intake, exhaust, turbocharger, or tuning changes. Monitor and record the MAF-Learn idle and MAF-Learn idle PIDs when available. If you find a real intake, crankcase ventilation, or charge air concern, repair that concern, then clear or reset the learned MAF function as directed by the scan tool path. Clear the PCM DTCs and repeat the self-test. If no concern is found, continue with the circuit integrity checks. If your diagnostic path lands on the intermediate sensor feed check, disconnect the MAF IAT sensor connector, turn the ignition on, and measure voltage from C128 pin 3 using the correct meter setup for that test. The pass point is greater than 10.5 volts. Record the MAF LRN idle and MAF LRN idle PIDs when available. If voltage is greater than 10.5 volts, continue to the open circuit checks. If it is not, repair the open circuit, then clear or reset the learned MAF function as directed by the MAF LRN values. Clear the PCM DTCs and repeat the self-test. If the meter hookup is not clear, pause and recheck the earlier diagnostic path before powering or condemning the circuit. With the ignition off, disconnect the PCM-B connector and check for opens in the MAF-related circuits. Measure resistance between C128 pin 1 and C123B pin 66, and between C128 pin 3 and C123B pin 51. Both checks need to be less than 5 ohms. If not, repair the open circuit, then clear or reset the learned MAF function, as directed by the path. Clear codes and repeat the self-test. If the opens check passes, check for a short to ground between C128 pin 1 and C128 pin 3. That resistance needs to be greater than 10 ohms. If it is not, repair the short circuit and verify again. Then check for a short to voltage on C128 pin 1. If any voltage is present, repair the short circuit. If no voltage is present, keep moving down the P0101 path. If the hard circuit checks pass, reconnect the MAF IAT sensor and the PCM-B connector. Then start the engine. Command the airflow-related controls to stabilize the test. Decrease EGR VPDES to 0%. Decrease TPDSD to 0%. Decrease EGR TP-CMD to 0%. And decrease VGTDC command duty cycle to 0%. Monitor the MAF PID, record the high and low values, and set the graph limits 4 grams per second above and below those recorded values. Now wiggle the harness from the MAF IAT sensor to the PCM while watching the graph. If the MAF reading breaks outside those set limits, inspect and repair the harness concern. If the harness does not show a concern and the reading still fails this intermittent check, a new MAF IAT sensor is supported by this path. After that, clear or reset the learned MAF function as directed. Clear the PCM DTCs and repeat the self-test. If the intermittent check passes for P0101, continue to the smoke test. For the next check, key off and remove the EGRT12 sensor. Bag the air filter to prevent airflow out of the intake port. Reinstall it. Connect a smoke machine or equivalent to the intake air system with the proper adapter, and fill the system with smoke. Regulate shop air to 137.9 kPa, that's 20 psi, before connecting it to the system, and do not exceed the damage warning. Pressure above 241 kPa or 35 psi can damage components. Check the intake air system for leaks and restrictions. If you find any, repair the leak or restriction. Follow the learned MAF clear or reset path. Clear the PCM DTCs and repeat the self-test. When this step is done, reinstall the EGRT12 sensor and remove the plastic bag from the air filter. If no leak or restriction is found for P0101, move to the MAF operation check. Start the engine and monitor the MAF PID. Set the airflow controls for the test by decreasing EGR-TP CMD to 0%, decreasing TP-DSD to 0%, and decreasing VGTDC CMD duty cycle to 0%. Record MAF at idle. Then monitor RPM DSD. Bring engine speed to 2000 RPM and record MAF again. On this F-Series Super Duty path, the expected MAF value is 30 to 36.8 grams per second at idle, and 116 to 125 grams per second at 2000 RPM. The companion values for other applications are 3.2 to 3.8 kHz all others at idle, and 5.5 to 6.3 kHz all others at 2000 RPM. If the MAF readings are outside the correct range for the vehicle being tested, install a new MAF IAT sensor. Use the MAF LRN values to determine whether the learned MAF reset is also needed. Clear the PCM DTCs and repeat the self-test. If the readings are in range for P0101, keep going rather than replacing the sensor on a guess. Some branches in this same intake air test move away from the normal P0101 path when the scan results point to humidity, temperature correlation, or pressure bias concerns. For the humidity branch, turn the ignition on, monitor REL HMDTY, record it and compare it to the daily humidity level. Indoor and outdoor humidity can be very different, so check it with the engine at ambient conditions and cold soak the vehicle outside for a minimum of 8 hours if necessary. For the temperature correlation branch, monitor AAT, CACT, ECT, EGRTA, and IAT11 with the ignition on. If needed, cold soak the engine for a minimum of 8 hours. IAT11 needs to be within 15 degrees Celsius, 27 degrees Fahrenheit of the AAT reading, within 16 degrees Celsius, 28.8 degrees Fahrenheit of the CACT reading, within 20 degrees Celsius, 36 degrees Fahrenheit of the ECT reading, and within 20 degrees Celsius, 36 degrees Fahrenheit of the EGRTA reading. For the pressure bias branch, monitor BARO, EBP, MAP-A, and TCIP. The suspect sensor should be within 4.5 kilopascal, 0.65 psi of the other sensors. If it is within that range, check the MAP and MAP CACT sensor for moisture, ice, or restriction and repair as needed. If these related branches fail in the direction of the MAF IAT sensor, a new mass airflow intake air temperature sensor is supported there, followed by clearing DTCs and repeating the self-test. If the early voltage check sends you into the alternate PCM DTC branch, run a PCM self-test and check for other PCM-related symptoms instead of forcing the P0101 path. If the air filter restriction code is the only PCM DTC, verify there are no obstructions in the intake air path. If none are present, this branch supports installing a new air filter, clearing the PCM DTCs, and repeating the self-test. If other PCM DTCs are present, diagnose those PCM DTCs first. For the main P0101 path, if the intake system, wiring, intermittent check, smoke test, and MAF operation check all pass, Then check the PCM connector side. Disconnect the PCM connectors, inspect for pushed-out pins and corrosion, reconnect them, and make sure they seat correctly. Then verify whether the concern is still present. If the concern is gone, the system is operating correctly at this time, and the fault may have been a loose or corroded connector. If the concern is still present after that connector inspection and reseating, this path supports installing a new PCM and performing the required programming. Keep verifications separate from the testing. After any repair, clear the PCM DTCs, repeat the self-test, and confirm P0101 stays gone. The takeaway is simple. Prove the air path, prove the circuits, prove the live MAF response, and only then condemn parts. For more diagnostic training, visit stepdiagnostics.com.